Like, because pretty much no light's coming through. If you rotate them at some point, it would seem like there's even more light coming through than just one alone.
The way I'm thinking, I'm not understanding exactly what you're saying, but for me it's not like an electrical parallel
like, when we were
series
talking about
circuit type
resistance,
thing.
I'm not thinking like resistance whenever, like if you have resistance, if it's in parallel, the
I'm going to put
resistivity
you off
is
for a
even
little
lower.
bit, because you're going to see something in a few minutes that will have an impact on your decision on that.
Okay.
I kind of saw that too,
Me
but I
with you
got
first. Usually that's done electronically now, digitally, but yeah, you could do that. I mean, before the digital age, yeah, that would have been a logical way to do a fade. Yes. All right. For step number 3. Oh, I'm sorry. Go ahead, Scott.
yeah, like I don't know if you want me to make this observation yet, but I saw almost like a harmonic motion idea. Like if you think about resonance and where we have like all constructive or all destructive. What was it? Adding.
Yeah, constructive interference was resonance.
Interference.
That's always
Yeah.
okay.
Like it seems like if you have it at one set, you can get it all destructive, and if you have another set, you can get all constructive.
What do you guys think about that one? He said that when they're in one orientation you had all destructive interference, and in another orientation you had all constructive interference.
So it gets brighter if you have it one way?
That's the part that the constructive interference is the one where I have an issue. The destructive interference, I can see that because it goes completely
Well, I'm
black.
not really saying. I'm
But
saying.
if it is constructive interference, then it would get brighter. And I don't think the two filters are ever brighter
Well,
than the single one.
what I meant by constructive is just making because like I'm saying these both are a little bit destructive on their own, and that any constructive force that they would have would just make it go back to plain, like clear.
I understand. And I think we'll clarify that thinking in just a second. Oh, by the way, if you haven't done this one yet, let's see, the one we did first, you held the far one still and you rotated the close one. Well, now hold the close one still and rotate the far one. And then summarize your observations in step 3.
Wait, so when I did step 2,
Same thing.
okay, I'm not getting
That's what I'm trying. That's what I'm feel like I should be doing, but it's just not quite working.
this Ruben.
Yes.
What I got was different when I did it, when I was moving the one that was closest to me. It would change every 90 degrees. So like, if I held it at this point, the one in the back is dark. If I rotate a little bit, that one becomes lighter. But there was a point where only this middle would be see-through, but everything around it through this lens was dark.
Okay. Probably the only thing you saw was the blues or the purples, those really high energy short wavelength lights. And we'll talk about that in just a second. So with the 90-degree thing, good observation. All right. Let me have your attention here for a second. Would you hang on to the end of this? Pretend that this is a light wave, okay? So you've got to have something vibrating to generate a light wave. And by the way, what is it that actually generates, we think, produces an electromagnetic light wave?
A moving charge?
A moving charge. So we've got some kind of a moving charge, so my hand will be a moving electron, okay? Now, suppose that I've got a light source like a filament in a light bulb. So I've got electrons that are bouncing in all different directions. I've got some electrons that are bouncing like that, and I've got some electrons that are bouncing like that, okay? Now, suppose that I had a picket fence. You guys know what a picket fence is, right? Okay? All these little vertical slots. And I put that picket fence between Jared and myself, okay? And so I've got waves vibrating that way and I've got waves vibrating that way, and I've got waves vibrating that way. And suppose I put that picket fence exactly halfway between us. Which waves would make it to Jared?
Up and down.
Side to side, in certain frequencies.
If my pickets are like this, what's going to happen to those waves? They're going to smack into them and they're going to get stopped. Okay? But the ones that are lined up with the pickets can make it right on through. Okay? So normal light, where the waves are vibrating in all different planes, we call that light non-polarized. But if the light passes through something, and maybe we stop a bunch of them, but we let only the ones that are vibrating in the vertical plane through, then we call that light vertically polarized light. Okay, just a second, good question. Now, what would happen if I take my picket fence and I rotate it this way? Okay. Now, the ones that are vibrating in the horizontal plane can make it through, but the ones that are vibrating in the vertical plane cannot make it through. So what happens if I've got two filters, two picket fences? I get two picket fences and they're both lined up vertically like this. Okay? What happens when the light shines through both of those filters? Which ones make it through the first filter?
Up and down.
Only the vertical ones, only the up and downs. So if the only thing that makes it through the vertical first filter is the up and downs, will they make it through the second filter as well?
Yes.
Yeah, because the second filter was also up and down. So as long as the two filters are aligned the same way, both up and down, or both horizontal for that matter, then everything comes through. Everything that made it through the first one will also make it through the second one. So when all the light was coming through, can you guys tell with your eye, is there much difference in the brightness between one filter and two filters when all the light's coming through?
No, not a whole lot.
Probably not much difference, right? But, like Austin pointed out, there is a difference every 90 degrees. So if you take one of the filters and rotate it 90 degrees, and it doesn't matter if it's the close one or if it's the far one, what happens when one of them is rotated 90 degrees? Suppose I got my two pickets here and they're both lined up vertically like this, and I take the near one and I rotate it like that. Waves vibrating like this, waves vibrating like that, waves vibrating all different directions. Which ones are going to make it through the first picket fence?
Vertical.
Only the ones that are lined up with that picket fence. And so if the first one is like this and the second one is like that, what happens between the two filters?
None makes it through.
They stop everything. One of them stops all the vertically oriented stuff. The other one stops all the horizontally oriented stuff. Between the two of them, they stop everything. Okay? Does that seem to match what you guys are observing? And when Austin said, if you had them perpendicular to each other, 90 degrees, sometimes you could see a little bit of light coming through in the center. If you do, actually, if you put it to the window and get it where it's as dark as you can possibly get it, you might get a little bit of light coming through. I bet it's going to be violet in color. It's going to be the purple light that you'll be able to see.
So what I'm doing right now is I'm holding this and like only the second lens is see-through, but everything around it is dark. Right at that point where I'm holding it.
Well, you're looking at an iPad, right? What does that tell you about the light coming from the iPad?
It's,
Look at it with just one filter.
then it's
And
all,
rotate your one filter in front of the iPad screen.
it goes light and dark.
So what's that tell you
It's
about
only
the,
going.
the light coming off the iPad is polarized? So when we were looking around before, you guys detected the computer screen up here seemed to change intensity with a single filter, and the iPad screens change intensity with a single filter, because that light was already polarized. And so when you rotated your filter, it was either coming through or you were blocking it. So the light from your iPad is polarized. If you try that same thing with a non-polarized source, like one of these lights directly up over here,
It doesn't come.
it won't happen. So the fact that one filter shows you that on the iPad screen shows us that iPad is putting out polarized light. Yes?
Here could be a question that's completely wrong, but what if you flip your sunglasses upside down?
Oh, good question.
That
In fact, polarized sunglasses are just like these filters that you have here. Do you think the pickets on the polarized sunglasses are arranged vertically, or do you think they're arranged horizontally, or maybe one of each?
I think you got
Go ahead and talk to the people sitting near you. Share ideas for a minute, and then we'll come back to class.
I feel like you have
No idea, but I got
one vertical or one horizontal, and then you have one that's like at an angle, so that you get parts of the light, but you don't get it all. And that, like, see, like, here's the first part, so that's like one polarized lens, and that's the vertical, and then as you turn it more and more light, and then you get 90 degrees, and that's what you can do to make a lens, if you can do to make something that you can use, because then you can drive, you see anything.
All right, let me have your attention back. Just indicate with fingers. How many of you think the pickets on your sunglasses are oriented this way, or or one of each?
Can we go with a third option? I mean, a fourth option.
What else
I
could there
didn't think
be?
there could be another possibility.
Yeah. Can I try it though?
Tell me which
No.
one.
You know how like we have it at one point we say we have it all going up, and at another point we have it all going over. I feel like there could be a way to have it in between.
Okay, so put them at like 45 degrees.
Well, like
okay.
one, you know, you're not going to turn both. Like you want one, like have one either vertical or one horizontal, and then you turn the other one so that it's matching up less. So
Well, when you're looking through your glasses, you're only looking through one lens.
well, so you can put that, but you can put two polarizations on
Sunglasses.
Well, couldn't you put like two films of separately polarized? Yeah, but have them like even like closer.
At all.
Well, see, that's what I'm saying though is like how when we turn it, it gets darker. And
So 42 lens. So each lens is two lenses, 45 degrees to each other.
yeah.
I'm with you. All right, those possibilities we're going to investigate tomorrow. The lenses that you've got, please put them back in the little Ziploc bag so we can get them back. So when we continue this tomorrow, you will have two lenses. Okay? So put those all together, put those back in the plastic tub on the back table where they were. If you have iPads out, I need those back up on the middle table. The light sources I need back on the boxes here. So please get everything that we had out, put back where you got it originally. Excuse me.
So Mr. Bergman in the lab.
Yes.